Okay, this is for Algebra 1. This is the second video. These are for your examples for 7-4, Solving Polynomial Equations, and this is on page 378. So hopefully you read through the examples to see a little bit of what's happening. And so let me just verbally describe what's happening. So first of all, this is a polynomial in factored form. Like if I gave you that and asked you to write a polynomial, you would distribute this. But now I'm already giving you in factor form, or they're giving it to us, and it equals 0. So what you're trying to find is if equals 0, you're trying to find the solutions or roots. They're called roots with these. They are called the roots of this problem in the fact of, like, you're looking for the solutions. What can x equal to make this true? What can x equal to make that true? So it can be more than one number. So there could be more than one number that makes this true. So let's think about this. You're saying 2x here times this equals 0. Well, in order to equal 0, and you're multiplying, that means one of these answers need to be 0 at one time. So what you can think about is this. You can think about, okay, so 2x can equal 0, or x minus 4 can equal 0. Because this can equal 0, this term here, or this term here can equal 0. Well, 2 times what gives you 0? 0. So x could equal 0, or x could equal, x minus 4 equals 0. So what does x have to equal to make 0? 4. So in this equation, either these, it could be 0, x could equal 0, or x could equal 4. So all I did here was I thought about these as two different terms, which they are. So the 2x can equal 0 to make that true, or the x minus 4 can equal 0 to make that true. Because if you plug this back in, not that you have to, but if I test, okay, so 2 times 0 times, oh, that's kind of confusing, but times 0 minus 4, well, 2 times 0 is 0. 0 minus 4 is a negative 4, and 0 times a negative 4 is 0. Or I can test 4. 2 times 4 times 4 minus 4. So I'm testing here. 2 times 4 is 8, but 4 minus 4 is 0. And 8 times 0 is 0. So what I'm looking for is what are the two solutions here that make this statement true, that equals 0. So it can be 0 or it could be 4. So your roots are x equals 0 or x equals 4. Okay? So on example B, they have x minus 3 and x minus 9. Again, what we're looking for are what are the two solutions that x could equal to make this true. Well, this means x, this whole term here, x minus 3, that whole value could equal 0, or x minus 9 can equal 0. So in order to make this true, what minus 3 gives you 0? Well, x can equal 3, or x can equal 9. Okay? If you're not convinced, plug them back in. But that's what you're doing there on that part. Now, let's see when something else happens. So let's look at example 2. So we have 2x plus 7 and 2x minus 7 equals 0. So they're already in factored form, which is nice, and it's already equaling 0. So we don't have to worry about anything else. Now we need to find out what can x equal to make that 0. Well, 2 times what plus 7 equals 0, or 2 times x minus 7 equals 0. So I'm thinking of what number times 2 plus 7 equals 0. Well, sometimes we can guess and check and all that, but just, excuse me, use your equations, like solve it by a two-step. If I subtract 7, I get 2x equals a negative 7. Oh, divide by 2. Notice it doesn't come out to a nice whole number. So it's going to, negative 7 halves. Go ahead and leave it. I mean, you could leave it like this. This is a simplified form for you. That's fine. Or if you add 7, 2x equals 7, x equals 7. Okay, divide by 2, x equals 7 halves. So you can have a negative 7 half or a positive 7 half. So this one is going to have two roots. Okay? Now you can change that to a negative 3.5 and a positive 3.5. Your answers are fine as an improper fraction. When we start graphing these, it'll make more sense to have a negative 3.5 and a positive 3.5. But we'll talk about that. Okay, let's look at B. Now be careful here. This x minus 1 squared equals 0. That means x minus 1 times x minus 1 equals 0. Well, these two are the same term. So what this means is you're saying x minus 1 equals 0, or x minus 1 equals 0, which that's going to be x equals 1, or x equals 1. Well, that's the same answer. So this is what we call a repeated root. That is a repeated root. The only answer, the equation has a repeated root, your only answer here is x equals 1. That's the only solution that would work there. And since it's repeated, you can list it just once. But that's meaning, if you ever hear repeated root, meaning one of those answers are repeated more than once. Okay, so let's see if on C, when you have 3, same concept. It's just now that you're going to have 3 roots. Well, this is kind of nice to where they all equal 0. So I'm going to have, if you want to do a quick, okay, go ahead and write this out. X plus 1 equals 0. I'm going to write it this way. X minus 3 equals 0, and x minus 2 equals 0. So you just have to say, okay, what is this going to equal? X is going to equal a negative 1 here. X has to equal a 3 here. And x has to equal a 2 there. So your 3 solutions, your 3 roots, are negative 1, 3, and 2. It's almost preferred to put them in order, but that's okay. That's no big deal. All right, now let's look at, try the monitoring progress as practice if you'd like. And let's just do one more like this. And I'm going to do that one that says 3s plus 5 and 5s plus 8. Because this is where most people have issues. You need to put these, that s and the 5, be careful. S plus 5 equals 0. Or 5s plus 8 equals 0. Now you're going to solve it. So you subtract 5. I'm going to come down here. 3s equals a negative 5. Divide by 3. Your root is going to be a negative 5/3. Or s is going to equal a negative 8/5. Okay? So if you just set them equal to 0, then your roots, your 2 solutions that make that true, you're going to learn that that's where it's going to cross the the x-axis. Okay? So what really it's going to turn in x and y. So when x is what number, y is going to equal 0. So that's where this is leading into, is when we start graphing. All right, so the last thing with this, the factoring polynomials using the greatest common factor. Pause the video now, and would you read this? So then when I'm saying it, it makes a little bit more sense. Okay, so factoring using the GCF. This is still on page, this is 379. Okay, the greatest common factor. So the greatest common factor, if we have 4x to the 4th plus 24x cubed, what you're trying to do is you're trying to pull out the largest, the greatest common factor of 4 and 24, and the most amount of x's that you can that are in both. So 4 and 24, the largest number that goes into both of these is 4. So it's like you're really dividing. So if you think about you're dividing, so I'm looking for, so 4 can go into both, and x cubed and x to the 4th. How many of these do they have in common? So they have x to the 3rd. So what you're really doing is dividing. It's like you're pulling, it's opposite of distributing. So 4x to the 4th divided by 4x cubed. So you're going to have 4x cubed, because I'm going to take that out. 4, this is going to be just x, because 4 divided by 4. So if you want to look at it this way, maybe do that. That might help you. So I have 4x cubed. This is just going to be x. This cancels. X to the 4th divided by x cubed is just x. Plus 24 divided by 4 is 6. X cubed divided by x cubed, well, that's 1. So that's your final answer there. That is in factored form, pulling out the GCF. That means if you distribute this back, you should get this answer. So if you're not for sure if you did this right, distribute back in and see if you came up with your original. So then to solve this, we would make that equal to 0. So that's when I said in the notes earlier that you wanted it in factored form and you want it to equal 0. Now you can solve this. So if we had 4x cubed equals 0, or x plus 6 equals 0. So if we made this an equation, if we made that equal to 0, well, in order to be 0 here, you got to be careful. Yeah, because 4, now 4, divide by 4, x cubed, 0 divided by 4 is 0. Okay, so what cubed equals 0? So x is going to equal 0, or x is going to equal a negative 6 in this type of situation, if it was equal to 0. Okay, I know that was kind of fast. Looking at your examples, so example 4, 2x squared plus 8x equals 0. I jumped ahead here. What number can you pull out of both of these? Well, 2. X squared and x. You can pull an x out of both. So you're going to have 2. That's going to be 4. So 2. Oh, wait a minute. 2x times x plus 4 equals 0. So now you have 2x equals 0, or x plus 4 equals 0. X equals 0, or x equals a negative 4. So those are going to be your two solutions that make that true. When you have this one, 6n squared equals 15n. Now here, notice what's not the same as the rest of these. These are not equaling 0. So what can you do to this to make this 0? Well, you're right, you can subtract it. So when you subtract 15n, you move it on to the other side, you have 6n squared minus 15n equals 0. So you want to get everything to equal 0. Now factor out. Find your greatest common factor. What's the lowest number? The greatest number that goes into 6 and 15. Okay, so that's going to be 3. And then how many n's can you pull out? 1, because that's n squared and n. So you're really dividing. So 6n squared divided by 3n would be 2n minus 5. So you're undoing your distributive property that you did before by greatest common factor. Now put it equal to 0. Again, you're finding the roots. N has to equal 0. Or if you add 5, you're going to get 2n equals 5, n equals 5 halves. So your two solutions, your two roots that make this statement true, is going to be 0 or 5 over 2. Okay? All right, so then you want to look at your homework. It is on your pink sheet, and workday is going to be on Wednesday. So if you're watching this all on Tuesday, then workday, you can go straight to workday and work it. If you're watching this Wednesday, you need to catch up on that, and then this is what is going to be, you're going to be working on Wednesday night, and possibly even a little bit on Thursday if we have time. So you want to, that is what your homework is there. All right, thanks guys.